So let's talk about today packages and interfaces. Mainly, I will be talking the interfaces. We have know that what is a class? Class contains variables, and also class contains methods, and methods we provide a complete implementation. But interface is almost same like a classes, but it has a little bit of difference from the class. The way you define the class, public class, you write the class name. Similar way, for the interfaces, public interface, you use a word called interface, like a class word, and you create a interface. So the interfaces will have a variables and will have a methods, but method will not have a implementation. We remember we talked about abstract methods. Abstract method is a kind of a method where we declare a method and we don't write a body for the method. Similar way, interfaces, we have write a method name and a signature, what is the input parameters, everything we will write, but we don't provide the implementation for the method. Who are going to give the implementation is the classes. The classes will implement the interface and they write the actual implementation. The advantage of this is the concept of interfaces they have introduced is because of to accomplish an inheritance in the multiple levels, multi-dimensional inheritance to accomplish. They have done this one, and there are a lot of advantages by using these interfaces, especially the code reusability, and also it helps for the loosely clubbing. It means when you're developing an application, you need to write hundreds of thousands of lines of code. Like 100 people are working in one project, multiple people are working in multiple projects. We need to define a reusability of the code, and we need to define a how efficiently writing the code with less number of lines. Ultimately, we will look at in this direction. The interfaces will help directly, indirectly in this way. So general signature of the interface is like, access specifier, which is the public. We refine the public, and you give an interface keyword. As we mentioned that class means we provide a class, and we need the give name of the interface. And you define the variables, what are the variables you want, a type if it is a string, and the variable name and value. And you define a methods, method 1, method 2. You can define the list of parameters and what are the return type. This is the basics of an interface. If you see an example here, I hope a screen is visible to everyone. If you see the here, I have defined interface, public interface employee. And I define a salary of 10,000 rupees, and I have given a bonus of 500 rupees. And employee house rent is 1,000 rupees, and employee name is John. And I have mentioned the method public int month salary, int salary, int bonus, int rent. And if you see here, I have closed the parenthesis and we have mentioned the semicolon. We have not provided the implementation for the method in the interface. We should not be providing implementation for the methods in the interface. It will not allow. Another method is employee department name and string bachelor's degree name. Employee department name, string bachelor's degree. What bachelor's degree has done it. The two methods are there in the interface: month salary and employee department name. So we define another interface, which is called department. And in this interface, We have a accounting department is equal to accounting department, HR is equal to HR department, admin is equal to admin. We define 3 strings here. So we have a 2 interfaces, and now we are going to write the class. Public class employee details implements. The keyword here we talked about a class can extend another class by using extends keyword, but here a class can implement interface by giving a implements keyword. We need to give this is the implements keyword so that Java virtual machine, when you compile the code, it understand that this is a class and we are trying to implement those so and so interfaces. We define 2 interfaces by comma separated employee, comma, and department. So I'm telling now employee details implements employee, comma, department. And this is the constructor which we have already discussed. The parameterized construction. I'm not going to explain more here because everyone is aware about this. And here we have provided the implementation now. Public int month salary exactly should be matched. Whatever you have written signature, exactly you should be matched. Month salary, int bonus, int rent should match exactly. And you open the parentheses and open the brackets and close the brackets. Here we are providing a calculation, actual implementation of the method. Salary bonus plus rent is equal to month salary, and we are returning the month salary. The similar way, I have provided a implementation for another method, employee department name, and string takes the bachelor's degree. If the bachelor's degree dot equals to finance, then he goes to accounting department. If the bachelor degree equals to HR administration, it goes to department of HR, else it will be in admin department. So we define interfaces like this, and we will implement in the classes. Everything is good. Why do you want to do like this? What kind of an advantage I'm going to get to do this kind of things? Generally, we will have this kind of confusion. I have a classes that is good enough to do this work. Why do you need interfaces? Classes also doing the same thing. Instead of writing these many interfaces, I simply write a class and provide the 2 methods. Why do you want to write an interface like that and implement it? This is a lot of burden for the programmers. We may think like that way. The biggest advantage is, as I mentioned, that when you are trying to buy something, we always look at cost-effective manner to buy something always, and see that how quickly we can how less cost we want to buy the products. We always think as a common man. Like if you think about companies, big companies, to develop a software, it takes years, many years it takes. If you take WhatsApp, it might have taken multiple years to develop an application, and the developers are not 1 or 2, hundreds of developers are working on the developing a WhatsApp parallelly. They develop parallelly. What do we need to do like this? So generally, any project, if you take in house construction, you have architects and we have a designers, and you have the construction workers who does the working. Architect have the complete visibility of the building a home, how we need to build and everything. The biggest advantage of this is if who are visualizing in a high level of developing application, they build this interfaces to connect from one system to another system. They define the architecture and they provide a high level design. And there will be a developers who needs to work on that. They don't know the complete visibility of the project. They will be focusing on the actual implementation. Think about a house construction. A person who is putting a windows, you don't know how the house looks overall. An architect is a person who has a complete understanding of the high level of the home. So a developer has been assigned this task, employee details. I given a task to one developer, hey, develop a employee details and implement the two interface employee department. He no need to think what methods I need to implement. He just take the interface. It is already defined by someone else who has more experience or architect level or design level. They take, oh, I need to follow this employee details. I need to follow the method signature like this. All I need to do is I need to fill up this method, what I need to fill up. That is one of the real-time advantages of the interfaces. And apart from that, we can accomplish the inheritance and abstraction. Abstraction means I have already defined here this person, employee details class, he has just blindly following what need to be implemented. So I have already abstracted here. Means that I given a high level view of the monthly salary. I define the methods in the top level and the implementation class will take care of how to implement. I have abstracted all my things here. Tomorrow, if you want to add a new method, I go and add it here and the implementation class has to implement that. That gives one advantages. And also it supports the multiple inheritance. Multiple inheritance means I'm implementing some packages from the employee class, employee interface. Some of them I can do it from the department also. In the previous example, I have mentioned extends can only extend one class. In the previous class can extend only one class. A class cannot extend multiple classes. A class can implement multiple interfaces. I can go for 100 interfaces like this. But class extends only one class. It cannot extend multiple classes. That is the limitation in Java to accomplish the multiple inheritance. But by using interfaces, the biggest advantage of using this interface, multiple inheritance. You get a inheritance from interface 1 and you get an inheritance from the interface 2 also. If you see that the relationship between the class and interface, class have a variables, instant variables, and you can create object for the class. For interface, we can create an object because interface is not a complete without a class. A class can have a methods, interface can have a methods, but there is empty methods. Class can define a different kind of access specifier, private, protected, public, where interface we use the public access file, public interface. The similarities between these things is a class can extend another class, interface also can extend another class. Here, example here, this interface, public interface department can extend a employee also. It means that department become a sub interface for the employee if really need. The meaning of this interface can extend another interface using extends keyword. A class can implement interface using implement keyword. Interface cannot extend implement cannot extend actually implement any class. A class can implement the interface, but the interface cannot extend any class. If you see the relationship here, a class can able to extend the class, like the way interface also can extend the interface, and class can implement interface, but interface cannot implement a class. So top level is the interface, and within that subclasses will be there, classes will be there. That classes will provide an actual implementation. I will speak the real world examples as you next slides so that you have a better understanding how this will help. There are a lot of real-time examples. You are using it already, interfaces, by working on your apps in the application, and we don't realize them how they are developed. I will go through those examples. Then I will pause for your questions. So if you see that multi-inheritance using interface in the big application development, you will have the hierarchy like hundreds of interfaces, thousands of classes, thousands of methods, and n number of variables we will be developing to build in a big applications. Take an example, iPhone is working currently and you are using it day to day. Android phone, you are using it day to day. How much of operating system has they have developed? How many applications they have built on the on Android app or iOS also, right? And you think about a WhatsApp, think about a Facebook, think about a Google application, Gmail application. Thousands of lines of development has been done. Programmer has developed the code, and we need to organize them in such a fashion. And in order to organize them, we use interfaces, we use classes, and we use packages. I'm going to talk packages also. And we need to have a clear understanding of about our application. In the real-time scenario, the biggest problem will happen like this. To build a Gmail, assuming that it might have taken 2 to 3 years. It might have developed in 1999, so somewhere like that. I'm assuming that. Now it is almost 24 years or 25 years. Gmail might have updated multiple times since from 1999 to till now. Every day, some issues they might be updating. The people who wrote the Gmail in 1999, they might have left the organization. They might have gone to somewhere else. They might have retired also. A new developers are keep on joining a Google organization and developing a Gmail continuously. But a code, whatever they have built it in 1999, still exists. Like I built a home in 20 years back, still exists, and we need to do repairs to the home as you make a progress. First, I build a one room. Then after a few years, I create another room on the top of the home. Again, I create another room on the top of the home. That's how we build a home. Similar way, in the Gmail, in 1999, they have developed, and they might have done a lot of enhancements, updates to meet the demand, and they have some issues also. How do organize all the code base? How do you manage this code base? It's very toughest challenge issues. And if there is some production issue, it means something is not working in the production. We need to fix it immediately. It's very tough to understand where the problem is there in the real scenarios. So if you have a defined interfaces like that way, in the Gmail example, if you take mail, if you see that split the Gmail, you just visualize in your brain about a Gmail for some time. You have a compose email, and you have a send email, and you do reply email. You see the inbox, you have a sent items, and you have an address book, and you have settings. Lot of functionalities you have been using day to day in your life. I'm trying to link that to the what I'm speaking here is that, so let's define a interface called mail. Let's define an interface called mail. What functionality mail does? Mail means I can send an email, I can read an email, right? Two functionalities I can do, send and read. Let's put an interface called public interface mail and define two methods, send email and read an email, and compose an email. You're doing a compose means you're writing email also. You build that compose email, and you do delete email, delete mail. You do all these kind of functionalities. So I define an interface called interface mail, and there is another interface called address book. If it's look at your Gmail address book, you have an interface called address book. You define an address book. Address book, you add your contacts, your friend name, all the first name, last name, and everything, and your email address and their phone number. You can write as much as in the address book, like a phone address book. So maybe you define another interface called address book. There, add a contact, delete a contact, update a contact. You see the methods. So architects, when you're developing application, they don't go how to add, they don't write the whole code. Think in a high level of the functionalities. We start building the interfaces logically. And again, if I go to the another interface in the Gmail application, you have different type of inbox, social media inbox, priority inbox, and different kind of inbox. And you click a mail, when I click a mail, it opens up your mail, which shows the body and your to list, your CC list, and you see all the contents in the body, and you have a button called reply all button, reply button, and also you see a lot of information in your email. Maybe you can define for that one other interface. I don't build a relationship like that. First, I will look at the functionalities developing the interfaces in the complex programming structure. Then, now I have defined interfaces. Now I have organized my high-level view, and I will ask a development team to build an interface, build an actual code of a mail. So let's define a class which does the actual work and implement the interfaces, whatever I needed for my accomplish my tasks. So I build a relationship like this. Class can talk with interface. One can interface to talk with interface two. I build the mail and everything is deployed in the production. All of a sudden, something is not working in the production. I need to find out a fix here. I will look at what functionality is breaking. The mail functionality having some issue. Someone has reported you. I don't need to look at hundreds of thousands of lines of the code. I know mail means I catch this interface. This is a problem in the mail, means this is the mail interface. I go to the mail interface and I look at the respective implementation classes and I start looking the problem where it is. I try to fix it. Second scenario, hey, we have done mail, everything is working fine. Let's add a new feature to the public. The public is looking for new features, or my competitor is a Hotmail, is doing a lot of good things. I want to implement something new. What should I do? I need to enhance a mail such a way that the people can use very easily. Let's go to the mail interface again and start changing the code in this area. Like the way this interfaces, we are helping in the multi inheritance can be, because multi inheritance means you are deriving from multiple interfaces, and your abstraction means, as I mentioned, that a mail interface is providing abstraction. I don't know how this class is going to implement, but this is what my methods need to be working for me. Abstraction means you are defining abstract in the very high level, and so that the derived classes can take care of the real implementation. If you see that in the real scenario, I have depicted very, very small diagram here. Interface 1, interface 2, class 12 means class 1 to means interface 1, interface 2, I mentioned class 12. And interface 3 and interface 4 is developed, are going to extend by another interface. And class 234 is extends the class 234. This is also class, right? This is also class. This I should have written here as a class 34. This class 234 is extending this class And also it is implementing this class. Don't confuse with interface here. It should be class. Class 3.4 should be. Class 3.4 implementing these two interfaces, and class 3.4, 2.3.4 is implementing this interface, and also it is going and extending this class. It means that this interface two are being used by this one, and same thing are going to be used by here also. It means that we talk as an address book here. Some of the functionalities this class also needed. Some of the functionality this class also needed. We are implementing like this. Like the way we can accomplish the lot of multiple inheritance by using the interfaces. If you say that real example, one more example which I'm going to explain here. How to authorize user ID password of Gmail to other application. All other web application connect with Google to validate Gmail ID password, and only Google company can validate the Gmail password. If you see here, when you log into Gmail, you enter user ID password. When you log into Meet, log into Drive, or log into your calendar, login into your anything, YouTube, some of the things, photos, you still need to enter the Gmail user ID password. Gmail is the one project, and calendars are in different project. Drive is different project. Photos are different project. Not only that, nowadays, other third-party web application also, they will ask you to enter the Gmail ID or a Facebook ID or a Instagram ID to log in, so that you don't need to create a user ID again and again. You might have seen that in other applications. It means that non-Google applications also trying to access the, you enter the Gmail ID, then they will let you access their web application with help of Gmail. It means that non-web application, non-Gmail applications also connecting to Gmail server to validate the user ID password. That's how it has been working currently. If you see like Gmail authorize is an interface, we might have Gmail company doing the interfaces. So Gmail also using it. YouTube also will use that. Google Meet also use it. So we define an interface called Gmail authorize, and YouTube also will try to use that implementation, and Google Meet also will try to use that similar kind of implementation. If you see in the high level code, public interface, Google Gmail authorization, we would define the method called validate Gmail, and we take user ID and password. We define this kind of a interface, Gmail authorize. And Gmail authorize impel, this guy has implemented this Gmail authorization. The way they have implemented is, hey, take the user ID password and connect it to the Gmail database and validate the user ID password. Gmail has provided that kind of implementation. And YouTube also need to do the similar kind of an implementation. So they also follow the YouTube authorization impel implements the Gmail authorize. And they also follow the same valid Gmail ID, string and password. And this YouTube does their authorization mechanism. It might try to connect to the Gmail also to validate the user ID password. Like the way interface is deciding the method signature, what parameters to be received, and rest of the subclasses can start utilizing this kind of an mechanism. Under real scenario, you might have a credit card with you or debit card with you. You go to ATM, suppose assuming that you have a ICICI Bank or Axis Bank or State Bank, you have a credit cards or debit cards. You might have seen a name on the credit card, Visa credit card or MasterCard. You might have noticed this kind of things. When you take your credit card, you go and put in suppose you are ICICI Bank, you go and put in ICICI Bank, you get a cash. If you have a credit card, a debit card of Axis Bank, you go and get it from the ICICI Bank, still they will give it to you. Even if you travel to different city where there is no Axis Banks, where there is no uh, ICICI Bank, there is a State Bank only. You go to State Bank and you put your debit card and credit card, still they give a money to you. You go to the merchandise store, you buy something, you swipe your credit card, still they give a products to you. How come your bank is in ICICI, your bank in Axis Bank? How come a merchant will give money to you? Who is authorizing your valid user? Your account is there in ICICI Bank. Who is validating for you? The validation is happening with a MasterCard provider or a Visa provider. They're doing authorization on behalf of your bank. Your bank is not doing authorization. They are doing authorization. They're giving money to you, or they are giving money to the merchant where you buy products. Whenever you swipe the card, they need to validate your card number and your name or your CVV code and expiry date. Visa maintain this kind of a validation. As soon as you swipe it, it goes and validate first this card is valid or not. And once it is done, they know that this card has given by the ICICI Bank, or this card has given by State Bank, this card has given by an Axis Bank. They know it actually. Whenever you buy 50 rupees or 100 rupees, they will let the transaction successful for them in the store. They pay the $50 to the store person, and they will detect that money from your bank account, or you need to pay the money back to your credit card. So institutions are different here. ICICI Bank is different, Axis Bank is different, and Visa is different, MasterCard, they are sitting somewhere else. When you swipe the card, that card is authorized by Visa. Visa has to provide some kind of a validation mechanism for everyone. All the systems are interconnected here. The interfaces will help you to define an abstraction. I mean, an abstraction is here. Visa will take care of how to authorize your credit card. The ICICI Bank, Axis Bank are least bothered about whether I need to validate a Visa or MasterCard. They're delegating this task to Visa company. They are defining interface called validate a card. And within that validate card, they know how to validate your credit card. They provided abstraction to ICICI Bank, Axis Bank, State Bank. How the credit card is validated, they don't even know it. They just delegated the task to Visa company. They do the they have developed inside a interface called a validate card. Within that, they take a parameter called card name, card ID, card numbers, and their expiry date and CVV code. They does the magic in behind the scene. They say a Boolean flag, true or false. True means valid, false means transaction is unsuccessful. This is one of the example. There's a multiple examples. The interfaces can help you to provide a multiple inheritance as well as it provide you for an abstraction, and also reduce the complexity of when you're developing a real applications. I will pause here for any questions on the interfaces from anyone. The next concept is the packages. We know that we discussed about the class. The class is I give an example long back. When you go to shop, we buy vegetables and we buy fruits, and we can carry them individually. What you do, right? We can get a bag and put it all these things in a bag, and you come home. It means that class is kind of a container which holds the variables and methods. Like the way we have hundreds of bags, it is very tough to carry them, all the bags. You need a big basket where you put everything, or a big kind of container you need. You keep all of them into one container and you ship it to them. And suppose a farmer will produce a lot of tomatoes. One more farmer produce a lot of onions. And they need to ship this to market. They put it in a big containers and ship from the farm to market, and from the market to, they will send to international also through in a ship in the containers. They pack them in a container. Within that, you will have all tomatoes, or you will see onions or something like that. The similar way, as the number of lines are increasing day to day, a developer continuously working, building the lot of code, and we organize them by classes. We organize them in the packages, interfaces. We organize them interfaces. We organize them classes. But still, you will get thousands of classes, thousands of interfaces. I want to break them into a smaller unit. If you going back to our Gmail, mail functionality, if you take a mail, which comes about sending email, deleting email, composing email, all the functionality related to mail. Again, address book, contacts, there's a lot of functionality related to the address book. And your settings, if you go to Gmail, you do a lot of settings. If you say setting page in the Gmail, you get a lot of settings. Each setting you need to adjust it. There is another functionality. You divide them logically: mail functionality, settings functionality, and also address book. You see that logically divide your application. And also you have a user settings. You have username, password, you set the username, email address, your photo, your avatar. You can do a lot of things. This is called account settings. You see that functionality I'm talking about, mail, and I'm talking very high level, mail, address book, settings, accounting. Each functionality to build, I get thousands of interfaces, hundreds of classes, and hundreds, thousands of lines of program has to be developed. We need to organize them. We introduce called a package. Package is packaging. Simple word of in English. Package means you pack everything into one thing. So package is nothing but a kind of a folder, technically speaking. Very simple word. You speak in the folder. Within the folder, you drop all our classes, you drop all our interfaces files, and you name that package called whatever the name you want. Like the way folder name in the Windows, you give a name. Package is nothing but organizing all our classes, subclasses, interfaces into a single unit will help for the packages. If you see an example here, so far I have not talked about package. Public class, skill demo 1. And we know the methods. I know the methods. So I put a name called update my skill 1 package. Here, I created one more package called update my skill. So 2 packages have defined here: update my skill 1, update my skill. And within that, one class is update skill demo 1, skill demo 2 is it. So I define the packages, 2 packages are defined. If you want to access this package here, I use the import keyword, import update my skill demo 1. We use it whenever you want to access this class. If you see your example in the the examples, tiny examples we provided here. Day 6, take an example in a day 6. Condition statements. If you see that SRC, you see the name called COM folder. Underneath, we have a BVS Pro folder. Underneath, we have a student challenges. I open any class here. I open any class here and take a look at the class. You see the package com.bvspro.student.challenge. You see, whenever you say dot, it means this is the one folder, this is a different folder, this is a different folder. I have organized them. Student challenges are coming in this class. So if you see the folder structure also, com BVS Pro student challenge, it should reflect here. If you put a dot here, it means different folder. If you put a dot, again another folder. You need to follow the folder structure also, and underneath you need to store the Java file, which is called the if condition Java. If you go back here again, there is a one more class called student switch class example. In this class, let's open this class, how he has written it. The package.bvs pro, because this is a folder structure is com.b. So underneath of SRC, com and bvs pro, they define the package com and bvs pro. Whenever you want to define the package, you need to define like this. Example in Eclipse, I created already let's create a project from scratch. Suppose I create a project. I create a application client project, something. So I give a project name is something like, my skill project. I give a my skill project name is given. I created my skill project. The default Eclipse create a structure for me like this. So you see the default created a main.java. Main.java, there is no package here. Default package will be there like this. Suppose I want to create a package structure. I create a new class, Java class. I give it package structure, like, up. I give it up package. I give a name, any name, and I gave here, like, up test. So Java file name. I save this file. So my package is up package, class is up test. You see that folder has been created automatically. Up package folder is created right now. I created one more Java class. One more Java class. Underneath up package, maybe I put like, ABC. I created ABC and up package. Underneath, if you need a packages, create a folder. So up package and down package. I created one more folder called dot and down package. Eclipse will give you like, but actually what is happening the behind the scene is you will be creating a structure like this. You organize like this. SRC, SRC, underneath you have a folder structure, packages. If you want to use this package, if you want to access this class, switch case example dot class, we need to access it. You need to use import dot com BVS Pro. Whenever you want to import any class, you need to follow like this same structure is, if you want to import this class in different class, you want to use it, you need to write like this way. Keyword is import com dot BVS Pro dot switch my example. This is how we need to write in anywhere whenever you want to import any class in the. If you see in this example, what I was talking about here, I want to use in the skill demo 3, I want to use a skill demo 1. I want to use 1 is equal to new skill demo 1. So before that, I have imported this call, update my skill dot skill demo 1. Update my skill. Actually, there is a typo here. Update my skill 1 dot skill demo 1. After importing that, I can use this class because I am in different package right now altogether. The advantage will help you is that it will avoid the naming conflicts. Like, in the one package, I can define a class ABC. Another package, I can define a different classes. Same name with ABC also. Packages will help you mainly to organize your code, pack it in a unit, single unit, which contains multiple packages, multiple interfaces, multiple classes. Everything you organize them in a big logical unit so that it helps for the organizing your code better and better. So packages are two types. One is that user defined, which we can define a packages. Java also has already given a packages already. Java util lang and Java util java.io. There is a many packages Java has already provided. If you go to the Java API, you might have not noticed it. Let me go to this one and I explain to you. I'm saying this to first time. This is all the Java inbuilt code, inbuilt functions. See how they have organized here. Java has developed a lot of code already for us, all the functions, and where we are talking about, this is called Java API. I've taken an example of java.lang. In the java.lang is a package. It has many interfaces. They packed all these classes in the java.lang. If you open any class, let's open the string class. It will be easy to understand. It says string class. They have already developed API. The package is java.lang. Class is equal to string. It implemented interfaces, serializable, char sequence, compatible interfaces. They have implemented already. Public class, final string, extends objects, implements many serializables. And within that, you see that a lot of methods are there. This is called application programming interface. We need to use this one for your development. So in this, you see that if you want to split a string, there is a method public string split string. And these many are all of the whatever I'm seeing here, all the packages. Java has built these many packages. When you click on the package, you get the respective interface, respective class. Like the way Java has already pre-built a lot of functionalities for us so that it will be easy for the code development. This is the example of this package where you can go through this. You just type in in internet Java API, you get this document. Just type Java API, you see that Java API help class frames. You get all this Java API. We use this in the day-to-day programming, which we are going to cover it in the subsequent classes. I'm just introducing the packages here so that I'm talking about packages. Packages nothing but organizing your code into a logical unit. It contains each package can contain interfaces and classes.